Alright, we are going to look at the Algebra 2 semester review. So I'm just going to go through in order, since I can't really do one of each type of problem because it's covering the entire semester. So number one, are the following functions, yes or no? If not, why is it not a function? So remember that graphically, to determine if something is a function, we want it to pass our vertical line test. So if I drew a vertical line anywhere on my graph, would it intersect my graph at more than one point? Alright, so if I drew it here, it only hits at 1. If I drew it over there, 1. So this one is, yes, it is a function. When it is not graphically represented, we have to look at whether or not any of our x values repeat. If our x values repeat, it is not a function. So this is mapping. If I look at this, these are my x values. If any of these have an arrow going to more than one output, then that means it is a repeating x value and it is not a function. So if I look right here, the -2 is assigned to 1 and to 6. That means this is not a function. Right, so the -2 is repeating. So on C, so this is table. I'm going to look at my x values to see if any of my x values repeat, and since they do not, it is a function. D, this is just a list of ordered pairs, same idea. I look at my x values, and as long as none of them repeat, then it is a function. Alright, number 2. This is the quadratics unit, and this is where we looked at parabolas that were in a modified vertex form, and they could open up or down, or left or right. When the squared is on the x, we know that this is an up or down. To determine which one it is, I go over here to look at my coefficient, or my number that's in front of my parentheses. If it is negative, then I know it's opening down. If it is positive, it would be opening up. So right now, I know that this is opening down. I can get rid of all of these, which means I only have 2 to choose from. Well, when I look at this form, it is a modified vertex form. This is still h and this is still k. Insiders lie. So my vertex on this one becomes -2, 1. So of these two that I was left looking at, which of them has a vertex of -2, 1? And that's h. Okay. If I look over here at B, again, the squared is on my x term, so it's either an up or down. This time I'm going to look at the number in front of my parentheses, and it is positive, so I know it's opening up. Well, lucky for us, we only have 1 that is opening up, so it is I. On C, now that the squared has moved to the y, this is a left or right. So this is a right or left. To determine which one it is, I'm going to go over here again and look at the number that's in front of my parentheses. If it is positive, it's opening to the right. If it's negative, it's opening to the left. This one is opening to the right. Well, if I look, I only have 1 that's opening to the right, so we have F. Last one, squared is still on the y, so this is still a left or right. If I look at my number in front of my parentheses, this time it is negative, which means it is a left opening. I have 2 that are left openings, which means I'm going to have to use the vertex. Again, modified vertex form. This is h and this is k. Remember that insiders still lie, so my vertex is 1, -2. Out of these, which one has a vertex of 1, -2? J. Alright, let's look down here at number 3. So what is the domain of the graph on the left? Remember that domain is left to right. I have arrows on both ends. So how far to the left is this going? And then how far to the right? Well, since it has arrows on both ends, I know that it continues on forever, which means my domain is -∞ to infinity. All right, number 4 and 5, we are looking at what parent function these go with. On number 4, this is a quadratic. We want to now look at what transformations are being made to that parent function of the quadratic. This 2 in front is a stretch. Insiders lie, so this plus 3 is actually going to move it to the left 3. And the outside does exactly what it says it's going to do, so this is actually telling me to go down 5. So to now graph that, my vertex gets to move left 3 and down 5. This stretch by 2, remember that affects my counting pattern. It will take all of these and multiply them by 2. So instead of going out 1, up 1, I'm going to go out 1, up 2. Instead of going out 2, up 4, I'm going to go out 2, up 8. And that is my quadratic. What is the domain of my quadratic? Well, it looks very similar to the graph that we just looked at on number 3. So it is negative infinity to infinity. Range, remember, is my y, so it's bottom to top. So what is the lowest this ever goes? Negative 5. It goes all the way up to infinity. It is including the point negative 5, and we always put parentheses around the infinity. All right, on number 5, we just went over a unit on these. These are the absolute value. Again, let's look at what transformations are being made to the parent function. Insiders still lie, so this is going left 3. Outside does exactly what it says it's going to do, so it's going to go down 2. So again, I have that vertex point on my absolute value, which is now going to be negative 3, negative 2. I have no stretch or shrink, which means each side has a slope of 1. And there is my absolute value function. Again, my domain for absolute values, just like quadratics, are negative infinity to infinity. So range, bottom to top, what is the lowest that this ever goes? I've got negative 2. And then keeps going, so it goes all the way up to infinity. All right, number 6, we are solving by graphing. So if we want to solve a system of equations, we are looking to see where 2 points intersect. This first one is a parabola, which is moving left 4, down 3, and then is being stretched by 2. So out 1, up 2, out 2, up 8, and before I can graph this linear equation, I need to go ahead and move the 5 to the other side. So to graph that linear equation, I start at the y-intercept of 5, and then I have a slope of 2. If I went up 2 and over 1, I'm going to go off the graph to the right, so I'm actually going to go down 2, back 1. And then I'm looking to see where my 2 graphs intersect. So if I look at that, they intersect right here and right there. So what are the ordered pairs right there? I have negative 4, negative 3, and negative 3, negative 1. And those are my 2 points of intersection. All right, on number 7, we are looking at graphing our parent functions. We've already done B and C on number 4 and 5, so let's look at A. This is our linear parent function. So I know it goes through the origin and has a slope of 1. So there is my linear parent function. Absolute value. Remember, it has a beginning at the origin and then has a slope of 1 on both sides to create your v. And my last one, y equals x squared, is your quadratic, which has a vertex at 0, 0, and then out 1, up 1, out 2, up 4. And then if I went any further out, it would go off my graph, so I'm just going to use those points. Okay. On number 8, we have the function 2x squared plus 3x minus 4, and we want to find f of negative 5. When we say f of anything, we are saying whatever is inside that parentheses, we want to replace our x's in our equation with that value. So this is telling me replace x with a negative 5. You can just put this directly into the calculator, but I do find that if you forget to put parentheses in specific places, it could give you the wrong answer. So I just go ahead and work it out by hand. So negative 5 squared is 25. 3 times a negative 5 is a negative 15. 2 times 25 is going to give me 50. And then I have minus 19. So I'm going to get 31. All right. Number 9, we are using a calculator to solve this system of equations by putting it into our matrices. Before I put it into my matrices, I want to go ahead and set up the matrix that I would be using. Remember that if you are missing any variables, you have to put a 0 as a placeholder. So if I look at this first equation, I have a y and a z. I am missing the x. So I'm going to start with a 0, then 3, negative 2, 13. Your second equation has x, y, and z, so I don't need a single placeholder there. Now my last one, I'm missing the y, so I have a negative 1, 0, 5, and a 7. Once I have my actual matrix, I'm going to go ahead and go to my calculator, so second x to the negative 1, and I want to arrow over to edit. I've already put it in, but remember that it is rows by column, so it is a 3 by 4. From there, I'm going to plug in the numbers that I just created on my matrix on my paper. And then I'm in a second mode, so it'll kick me back to my main screen. Now I need to go get the RREF. So to get my RREF, I go back to second x to the negative 1, and this time I'm going to go to math. From math, it's actually easier to arrow up until we get to RREF, and I'm going to choose that. It's going to take me back to my main screen. Your cursor is blinking right here because it's waiting for you to tell it which matrix do you want to use. So I go second x to the negative 1, and then hit enter. This is saying that we're going to do the RREF on matrix A. So I hit enter. Remember that my RREF matrix needs to be all zeros and ones, and then the last column is my actual solution. So the solution to this system is negative 2, 5, 1. So I'm going to go ahead and write down that matrix so that I can see my RREF, so that my solution is negative 2, 5, and 1. All right. Solution to a system of equations in a table. Remember that solution to a system is the point where they intersect. So that means they have the same x and the same y. If I'm looking at a table, because the x's are not on here twice, these are just on here once, I'm looking for where the y's are the same. So right here, both of my y's are the same, which means they intersect at the point negative 3, 8. If I want to convert this into standard form, remember that if I say that something is squared,